Scientific notation is the topic of the day, and we look at this because we can have either very large numbers, or teeny little itty tiny numbers, and it can be terrible to write those. So we use scientific notation to be able to sort of shortcut some of these huge large numbers we see. Okay. Now we will have when we have a positive number written in scientific notation, it's written as the product of the number, and we can use a variable for that to describe it, which I'll explain here in a moment. But negative numbers, we're going to be looking at an instance where we'll have negative exponents, and for positive numbers, we'll have positive exponents. So when we talk about this, if we have a positive number is written in scientific notation as product of a number, and we're going to say that number is a, where a is between 1 and 10, okay, and it has to be to the integer power. So a positive number will be a times 10 to, really it's going to be a number, but we're going to say r for now. Now if we have a negative, or a very, let's say, I shouldn't say negative, but what I should say is very small. So large positive, if we have a small positive number, which is a tiny, minuscule number, then we'll look at a case where we would have something like a times 10 to the negative r. Now remember, we're looking at powers of 10 here. So if we had a number like 2.167 times 10 to the third power, well, 10 to the third power, 10 to the third is equal to 1,000, which, if we multiply 2.167 times 1,000, all we're doing, 2.167 times 1,000 is 2167. All we're doing is 1, 2, 3. If we look, we're moving a decimal point the same number of places we have our exponent in scientific notation, right? So we look at this, and I'll give you a couple examples of some instances where we may see these things. We can see a number like 5.906 times 10 to the 9th power. And this actually is the distance from the sun to Pluto, believe it or not. Okay. Now, this is in kilometers, I should say that. So if we looked at this, 10 to the 9th would be the same as a 1 with 9 zeros. So we're really looking at a billion. So it's 5,906,000 kilometers from the sun to Pluto. So we write that as 5,906,000. So instead of writing this whole thing out, we can write 5.906 times 10 to the 9th. I mean the same thing. So when we're writing numbers in scientific notation, a couple things we need to remember here. Okay. Number one is we want to move the decimal. This is the easiest way to describe it. We're going to move the decimal in the original number to the left or the right, so the new number has a value between 1 and 10. So we move the decimal to the left or right. Okay. So the new number has a value between 1 and 10. So the new number has a value I'll just say value between 1 and 10. Okay. Now this includes 1, but what we're saying here essentially is when we do this, when we look at this, like we have 5.90 times 10 to the 9th. We're moving the decimal left to right, so the new number has a value between 1 and 10. Yes, that's true. The second step, then, we'll get some light to this. In the second step, we're looking at counting decimal places, so we want to count number of decimal places. Count the number of decimal places. Decimal point is moved. So number of decimal places moved in step 1. Okay. Now, if we're, let's see, how do I put this? Greater than 10, we have a positive number. Okay. If it's greater than 10, it becomes positive. If it's less than, greater than 10, if it's less than 1, then we have a negative exponent. Okay. And then the third step is to multiply the new number. Multiply the new number from step 1 by 10 raised to the next power equal to the count in step 2. Okay, so multiply the new number by 10 raised to an exponent. Let's see how do I word this. It's equal to the count in step 2. Okay, well, what does that mean? Well, what that means, let's look at it exactly. Let's take 367 million. Okay. We want to move the decimal points. When we're doing scientific notation, the most important thing, and I'm going to start this, is that we can only have one number left of the decimal point. Meaning, we have 367 million here. Well, we know the decimal point would be here. We want to move it to here. We can only have one place to the left of the decimal point. So how many places are we moving it? 1, 2, 3, 4, 5, 6, 7, 8 places. So we want to take 367 million and put that into scientific notation. We have 3.67 times 10. Remember, we moved this 8 places, so 10 times the 8th power, and there's scientific notation for 367,000. Now, let's look at a smaller number, a number that's less than 1. So say we have 0.000013. Okay? Now, if we want to change this into scientific notation, what we're going to do is think, okay, 1, 2, 3, 4, 5, because remember, we want only one place to the left of the decimal point. So, if we're moving this 1, 2, 3, 4, 5 places, we're going to have 1.3 times 10. Now, since we moved it to the right, this is a negative number, times 10 to the negative 5th. So, when we are writing numbers in decimal format, we take the original number that we had, no matter how large it is or how small. It could be 2,416. And what we want to do is move the decimal place. Again, this is the decimal would be here. 1, 2, 3 places. So we have 2.416 times 10 to the third. If we have something like, again, 0.00183, well, 1, 2, 3 places here again. We have 1.83 times 10 to the negative 3. So I hope this helps a little bit on writing numbers in scientific notation. We'll be back again and have one about converting numbers from scientific notation to standard form. So have a good one. Bye.